Hello students, welcome to 7th lecture of D and Block Elements Competitive. Now today we are going to discuss about zinc and its compounds. Now occurrence, zinc does not occur in native form, that means its normal metallic form, because it is one of the very reactive metals. The chief ore of zincs are zinc blende, that means sulfide, calamine or zinc spar and zinc sites. So extraction process of zinc blende after the concentration by Froth flotation method, because it is sulfide ore, so usually sulfide ores are concentrated using Froth flotation method. It is roasted in air to convert into oxide. In case of calamine ore is calcinated to get zinc oxide. The oxide thus obtained is mixed with crushed coke and heated with 1673 Kelvin temperature. So it is very high range of temperature, because normally zinc do not get reduced because of its high reactivity. So that's why we need very high temperature, so that we can increase the reactivity of carbon used as a coke. So in fire clay we have to heat it, then ZnO gets reduced to metallic zinc. Being volatile at this temperature, metal distills over and it condensed, leaving behind cadmium, lead or Fe like impurities. So in short, zinc is very volatile metal. At lower temperature we can vaporize it. Lower temperature, that means comparing with other metals. So the crude metal is called spelter. The metal may be refined either by electrolysis or by fractional distillation. So most of the case you will notice refining process includes electrolysis processes, because in electrolysis we only need pure and impure metal rods and no other reactants are required. So that's why it is comparatively easy process. Now let's talk about the properties. As mentioned earlier, it is very reactive metal, so in most of the cases it will react with given reactants. So zinc is more reactive than the mercury. It is good conductor of heat and electricity. Zinc readily combines with oxygen to form zinc oxide. Pure zinc does not react with non-oxidizing acids, but the impure metal reacts forming Zn plus 2 ion by evolving H2. If you check the reduction potential of zinc, then it is in negative minus 0.76. So it represents its normal nature is to being oxidized, and it will behave as good reducing agent. For hydrogen, reduction potential is 0, so it simply represents with zinc hydrogen will be reduced and zinc will be oxidized. So simple reactions are mentioned. Zinc plus HCl reaction is also used in laboratory production of hydrogen gas. Okay, suppose our target is to produce hydrogen gas and then we need to identify it. So this is a simple practical which can produce hydrogen gas. Zinc solid and HCl together it will form a hydrogen gas. Now with hot H2SO4 it liberates SO2 gas and it gives ZnSO4. Zinc also reacts with both dilute HNO3 and con HNO3, liberating nitrous oxide N2O and ammonium nitrate NH4NO3 and nitrogen dioxide NO2 as mentioned in these reactions. Zinc dissolves in hot concentrated NaOH forming soluble sodium zincate as mentioned follow. Now special variety of zinc, zinc dust, it is prepared by melting zinc and then atomizing it with the blast of air. Atomizing, that means we are collecting the finely divided powdered form of the given compound. So simple thing, first we have to vaporize something or melt something, and then we will try to cool it down so you can get it in powderous form. So it is called zinc dust. Then we have granulated zinc. It is prepared by pouring molten zinc into the cold water. So it is molten and instantly cooling it will convert it into granuled form. Both these varieties of zinc are used as a reducing agent in the laboratories. And as we know, zinc is very reactive metal. So as we increase the surface, more and more reactivity will be obtained and faster reaction can be achieved. So granulate form, it is comparatively smaller pieces of zinc, and dust form, it is even very finely divided form of zinc, so it will be very reactive and it will give us quick reaction. Then we have compounds of zinc. First is zinc oxide. It is obtained by the burning zinc in air or by heating zinc carbonate or zinc nitrate. So reactions are mentioned. With zinc carbonate it releases carbon dioxide gas, with zinc nitrate it releases NO2 gas. So it is white powder but becomes yellow on heating and again white on cooling. It is insoluble in water and is very light and hence commonly known as philosopher's wool. It is amphoteric in nature, so it can act with acid and base with both as mentioned here. Zinc oxide with acid gives zinc chloride and zinc oxide with NaOH gives sodium zincate. Now zinc oxide with NaOH in different amount, it can create complex compound of zinc known as sodium tetrahydroxozincate. Now note here, our complex compound is by charge negative ion. If we check the oxidation state, because 2 Na plus are attached, that means oxidation state of our negative ion complex ion should be -2. We have 4 OH, so that means 1 OH is in -1 oxidation state, 4 will give us -4, so zinc should be in +2 oxidation state. So although our main metal is in positive oxidation state, and in all the cases you will notice metal atoms are either neutral or positive ions, still add suffix is added. Usually add suffix is added after the name of negative ion, but because of negative charge of our complex, which is -2 in this case, we have to attach add suffix after the name of metal, so that's why it is mentioned as zincate. Next, it is reduced by both carbon and H2, and it uses as a white paint. Zinc plus carbon, it gives zinc oxide plus carbon gives zinc metal and carbon monoxide. Similarly, zinc oxide with hydrogen gives zinc and H2O. Now these reactions are not easy. Okay, as we know, zinc is very reactive metal, so normal state of zinc is ionic state. That means it will be stable in ionic form and it will be unstable in metallic form, but still it can give this type of reaction, but we require very specific type of conditions. That means very high temperature and high pressure conditions. Next is zinc chloride, ZnCl2. It will be ZnCl2. It is obtained when zinc metal and zinc oxide or zinc carbonate is treated with HCl. It catalyzes as zinc Cl2 to H2O and becomes anhydrous on heating. Anhydrous, that means removal of water and dried form of compound. ZnCl2 is highly deliquescent, that means it is moisture absorbing compound. It will liquefy by absorbing moisture from the atmosphere and it is highly soluble in H2O. So simple thing, deliquescent nature will be mostly always soluble, highly soluble in water, and also readily dissolved in organic solvent like acetone, alcohol, ether, etc. Its aqueous solution is acidic due to the hydrolysis. So as the reaction suggests, ZnCl2 will release Cl and H2O will release H plus, and with the combination of H and Cl you will get HCl. Remaining OH minus ion will be attached, or it will replace the Cl minus as ZnOHCl. So in this reaction no oxidation states are changed. Anhydrous ZnCl2 is used as Lewis acid catalyst in organic reactions mixed with moist zinc oxide. It is used for filling teeth and its solution is used for preparing timber. Anhydrous ZnCl2 used as a Lucas reagent with con HCl. These uses are already mentioned in other unit, but it is also included in this unit. Next, zinc sulfate ZnSO4 and 7H2O attached with it. It is commonly known as white vitriol and it is obtained by the action of dilute H3SO4 with zinc metal as discussed earlier, or with zinc oxide or with zinc carbonate. So reaction was already mentioned. On heating, it first loses 6 molecules of water of crystallization at 373 to 723 Kelvin. It becomes anhydrous and on further heating it decomposes. So ZnSO4 on heating gives ZnSO4H2O. 6 H2Os are removed. Then on more heating it decomposes in zinc oxide, releasing sulfur dioxide gas. So these reactions are usually used in gravimetric analysis. In future, in further studies, when gravimetric analysis methods will be used, in those methods most of the metals will be converted into their oxides form, and then we can calculate their percentage in given unknown sample. It is used to prepare lithophone, a white paint, and also galvanization of iron. Now galvanization iron, that means it is a type of method which protects iron from rusting. Zinc being more reactive, when we form a layer on the given metal as mentioned here iron, it will protect the metal from rusting or outer atmospheric attacks. And it is also used as eye lotion. And further, it is also used as a medicine as a name of milk of magnesia for skin treatments. In next lecture we will discuss about the mercury and its compound.